In this video, I'll be showing you how to install Oracle Access Manager WebLogic cluster in AWS Cloud. Here is my architecture. I'll be using AWS Application Load Balancer to load balance Oracle Access Manager Node 1 and Node 2. And Oracle Access Manager Node 1 will have admin server, OAM server 1, and policy server 1. And Oracle Access Manager Node 2 will have OAM server 2 and policy server 2. And these servers are spread across two different clusters. One is OAM server cluster and another one is policy server cluster. OAM server cluster will have OAM server 1 and 2. Policy server cluster will have policy server 1 and 2. And these two application nodes will connect to Oracle Database 19c. In this video, I'll not be showing you how to install Oracle Database 19c. You can look at my other video on how you can install Oracle Database 19c in AWS Cloud. To create an EC2 machine, we require a basic network setup to be done in AWS account. I have my new AWS account created. Now I need to configure a basic network setup, which is creating a VPC and assigning subnets to it. When you go to a VPC page, I don't have any VPCs. So now I need to create a VPC. And the CIDR block, you can choose the default CIDR block, or you can customize it with your own IP address. We are not choosing any IPv6 CIDR block, and the tenancy is default. Now create. VPC is created and it has its own IPv6 address here. Now once a VPC gets created, we need to create subnets. In AWS, we will have 3 different availability zones. For each availability zone, we require to create one subnet, or you can create only one subnet for one availability zone. It's up to you. But I'll create 3 subnets for 3 availability zones. Select the VPC which we just created, and the availability zone. These are the 3 availability zones in Sydney region. So I'll be selecting 2A for subnet 1, and for each subnet we need to create VPC CIDR. I'll be selecting 1. So this is my CIDR block 10.9.1.0 24, and then create. I have one subnet that gets created in availability zone 2A. Now I need to create remaining 2 subnets. I'll copy this, select the VPC, availability zone 2B, and my CIDR for that particular subnet will be 224. And then create another subnet. Select the VPC, availability zone 3, and the CIDR should be 324. Now I have my 3 subnets created in 3 different availability zones. These are called as private subnets because you don't have any internet gateway attached to it. If you don't have internet gateway attached to it, your EC2 machine will not be able to talk to internet and download any RPMs that required. So create internet gateway. Once you create an internet gateway, you should attach this internet gateway to a VPC, which we just created. Once we have created internet gateway and attached it to the VPC, We now then assign the newly created Internet Gateway to our route table. Add a route table and select 00 Internet Gateway and select the one which we created now. Once we save the route, it is assigned to our route table. Now you can see under the subnets route table, you have the Internet Gateway here. For each subnet, you can see the Internet Gateway. So now these subnets became public subnets, which means whatever the VMs or EC2 machines that you create under these subnets will have internet access. So this completes a basic network setup for our EC2 machine. Let's create EC2 machines now. Launch an instance. This time I'll be using Oracle Linux. So if you search with this ID, you will get different versions of Oracle Linux. I'll be selecting Oracle Linux 8.2. And T2 large is the right size for us, which has 2 vCPUs and 8 GB of memory. We require one instance at the moment. We will be configuring second instance later. And subnet will be subnet 1. Public IP should be enabled. And then next, storage. For root volume, we need 10 GB. For E01, we require 30 GB. And for swap, we require 20 GB. We are not adding any tags. And the security group. Either you can choose an existing security group or create a new security group. So I'll be creating a new security group, and it requires access to port 22 on my IP, and it requires 7001 port number on my IP, and it requires 14,100 access from my IP, and then launch. I have my existing key pair. Otherwise, you can create a new key pair. I'll be naming this instance as OAM node 1. Use the public IP to create a session. And select my private key. And I'm naming it as OAM node 1. Now we need to configure this particular EC2 machine. Login as root user. While configuring this machine, I'll be copying my files. Now let's set a hostname to it and preserve that particular hostname even after reboot, and add this hostname in etc host file and add it here. Once hostname is set, I need to configure my partitions. First, I'll configure swap, which is xvdc. Make swap, switch on the swap, get the UUID of that particular volume, and add that volume in FS tab so that whenever this machine restarts, it automatically get attached to it. And next, I need to configure my E01 mount, which is xvdb. Once partition is created, I'll create a directory E01 and then mount that particular directory to our volume, get the UUID of that volume, and add it in FS tab. Once we configure our volumes, we need to set Oracle related parameters in limits.conf. And now we need to set parameters in cctl.conf. These are Oracle recommended settings and can be applied to any virtual machine. Now let's configure SSHD. Change it to yes. Password authentication should be yes, so that we can log in as Oracle user, and public key authentication should be yes, and client interval should be more than 600. Let's restart SSHD, create a group, create a user and add user to a DBA group, change password of Oracle user, change password of root user, go to U01 and create FMW directory, soft and Java directories, and change the ownership of U01 to Oracle and log in as Oracle user and export Java environment variables. Now we need to install all these RPMs. I have installed all the RPMs. Now we need to open up port numbers. 7001 is admin server port number and 14100 is OAM server port number and 14150 is policy manager port number and 5556 is node manager port number. And reload firewall. What will happen now is VM will allow incoming traffic on these port numbers. Otherwise, you will not be able to access any services within this VM from outside. Node 1 configuration is completed. While we are waiting for the files to be copied, I'll create node 2. Instead of creating node 2 from the scratch, I'll clone the node 1 and then create a node 2 from that clone. So to clone the node 1, first I need to take a snapshot or create an image and select no reboot. Otherwise, your download will fail. Let's wait for this image to complete. Our snapshot is ready and let's launch an instance. Subnet 1 and make sure we have public IP enabled. Click add storage, leave the same, and then security group is the one which we created, OAM group. Review launch and then launch using the same key pair which we used to launch node 1 and name this one as OAM node 2 and copy the public IP and start a new session as EC2 user, same key pair and name it OAM node 2. Now we can log in as EC2 user to OAM node 2 and we need to set host name as dev-OAM02. Go to etc host file and change the IP, copy the internal IP and change from OAM1 to OAM2. Let's go to etc host and add an entry here. Make sure we add the same entry in node 1. Let's restart node 2 after setting the host name. Now log in as Oracle user to node 2. This concludes node 2 configuration and let's wait for the files to be copied on node 1. Let's also add database entry in etc host file on both the nodes. Now files copy is finished. Let's move them to U01 soft. Oracle, make sure we have Oracle ownership on U01 and let's restart node 1 before we install Weblogic. In the meanwhile, we also have to enable communication between these three nodes. In AWS, we have security groups. Click on OAM security group. Now you can see that we are able to SSH from my IP. If OAM nodes has to connect to database nodes, or if you want to connect to OAM nodes from your browser, we need to enable all the traffic within the VPC. For that, we need to add a rule and say 10.9.0.0.16, which is our VPC CIDR, and it says all traffic within that CIDR should be enabled. Save rule. We need to do the same thing for database security group. Allow all the traffic within our VPC CIDR. Let's log into node 1 as Oracle user to start the installation. Go to U01 soft. Let's extract Java into U01 Java and then start installing Weblogic. I'll keep my Aura inventory in U01. Click next, skip auto updates, and my Weblogic Oracle home will be U01 FMW. Click next. All prerequisite checks have passed. Next, and then click install. It's completed. Next, and then finish. Now we need to install Oracle Access Manager. Let's unzip and then start the installation. I'll keep our inventory in U01. Click next, skip auto updates, and Oracle Home for Oracle Access Manager is also U01 FMW, where we installed our WebLogic. Click Next. Prerequisite checks have passed. Click Next, and then start installing. It's completed. Click Next and finish. Now we have installed WebLogic and Oracle Access Manager in Node 1. Now we also need to install WebLogic and Oracle Access Manager in Node 2. Instead of installing it from scratch, what I'll do is I will tar FMW directory from Node 1. Once tar is completed, let's SCP this particular tar to second node. Once SCP is completed, let's go to second node and then untar FMW in U01. Untar is completed in U01 in Node 2. Once we have WebLogic and Oracle Access Manager ready on both the nodes, we need to start running RCU, which is Repository Creation Utility, to install schemas, to install Oracle Access Manager schemas in the database. So let's go to U01 FMW Oracle Common Bin. And by the way, we are running it from Node 1. Click Next, System Load and Product Load. And we need to provide host name of the database, port number, SID, sysuser, and password. Click Next. Ignore this warning. Click OK. And the prefix, you can specify any prefix, but I'll leave it as dev and choose Oracle Access Manager. Once you choose Oracle Access Manager, it will automatically select its dependent components. You can also select Identity Manager if you are installing Identity Manager or OAM, but we are only installing Oracle Access Manager at the moment. Click Next. Provide common password for all the schemas that it is going to create. Next. It's going to create table spaces. Let's click on Create. Now it's going to create schemas and load all the objects into those schemas. It's completed. Click Close. Now we have all the schemas available in the database. The next step is to create domain. For that, I need to get into Common Bin and run config.sh from there. By the way, we are running it from Node 1. Create a new domain, and I'll be naming it as OAM domain. Click Next and select Oracle Access Management Suite, and it will automatically select its dependent components. Click Next. I'll leave application domain location same and specify the password for WebLogic user. Click Next. I'll keep it as a development mode so that we don't need to create boot.properties. If you select production mode, you have to manually create boot.properties after domain creation. Click Next and specify database details, devdb. If you have different prefix for schemas, you need to change that particular prefix here instead of dev. Get RCU configuration and then click Next. It will validate all the schemas. Click Next. We need to select admin server, node manager, and topology. That means we require admin server, we require node manager, and we require clusters and managed servers to be configured. Click Next. And in admin server configuration, we need to specify the host name of node 1 as we are installing admin server on node 1 as per our architecture here. I'll leave port number 7001 as it is. Next. And specify node manager credentials. Click Next. In manage server section, by default it will show you one OAM server and one policy manager. We need to add OAM server 2 and policy manager 2, and make sure we specify the host names. We are installing OAM server 1 in node 1. That's why I'm specifying node 1 here. And OAM server 2 will be on node 2. That's why I'm specifying node 2 here. You can see node 1 and node 2. And the port number should be same on both the nodes. OAM server 2 will have 14,100 and policy manager will have 14,150. And make sure you select OAM managed servers for OAM server 2, policy manager server. Then click Next. In cluster configuration screen, we need two clusters. One is OAM cluster and another one is policy cluster. Make sure you're not selecting any dynamic server groups. Click Next. We don't require any server templates and we don't require any dynamic servers. Make sure nothing is selected here. Now we need to assign servers to the clusters that we created. For cluster 1, we require policy manager 1 and OAM server 1. Now we need to assign servers to the clusters that we created. For OAM cluster 1, we require to assign OAM servers. For policy cluster, we need to assign policy servers. Then click Next. Next, we don't need to change anything here. Machines. As our architecture has two machines, OAM node 1 and 2. We need to create two machines here, OAM machine 1 and then OAM machine 2. Make sure you specify the complete host name here. For machine 1, it's a node 1. For machine 2, it's a node 2. Make sure you have exact host name specified for machine 1 and 2. And the node manager port numbers are same. Click next. Now we need to assign these servers. Now we need to assign the servers to those machines. For machine 1, admin server, policy manager 1 and OAM server 1. For machine 2, policy manager 2 and OAM server 2. And then click next. We don't have any virtual targets. Click next. We don't have any partitions, configuration summary, and then create. It's completed. Click next and finish. We have domain ready in node 1. Now we need to start node manager in node 1. We haven't configured anything in node 2 yet. Start node manager. Make sure it is not throwing any errors and make sure that it is listening on 5556. Clear the screen and start Weblogic, which is admin server. My admin server started and it is in running state now. Now let's add public IPs in my Windows host file. Copy node 1 public IP and then paste it here, and node 2 public IP and paste it here, and then save. Let's access admin server. We have all the servers here except admin server. All the servers are in shutdown state. Now let's shut down admin server and then shut down node manager. Make sure you have nothing running as Oracle user in node 1. So as we have created domain in node 1, we need to propagate this domain into node 2. For that, I need to pack the domain from node 1. You can see I have specified my domain location and where my package has to be saved and the domain name. So it has saved jar file here with the domain configuration, and I need to SCP this to my second node into U01. It's done, and let's go to second node. Now you can see you have domain jar. We need to unpack it. We only copied FMW from node 1. We haven't copied Java directory. So let's copy Java directory from U01. I have Java now. Let's go to Oracle common bin and unpack it. I have specified my domain location and my template file location, so it will automatically extract user projects directory into U01 FMW. While it is getting unpacked, let's start node manager and admin server from node 1. Start it and then start admin server from node 1. Let's go to node 2. Unpacking is done. Now from the same location, start WLST, which is Weblogic scripting tool. What we need to do now is from second node, we need to connect to admin server on first node. In the node 1, admin server is getting started. After it starts, we need to connect to admin server from node 2 and then register the node manager of node 2 with admin server of node 1. Let's wait for the admin server to start. My admin server has started on node 1. Now let's go to node 2, dev OAM1 on 7001 port number, which is admin server port number, as a Weblogic user and its password. It got connected. Now we need to enroll the node manager. So nm enroll, node manager enroll command will provide the domain location as well as node manager location on node 2. Now it's successfully enrolled. Let's disconnect from admin server and exit from WLST tool. So we have successfully enrolled our node 2 with node 1 admin server. Let's start node 2 node manager. Start node manager. Once node manager is started on node 2, let's go to admin console as a Weblogic user, and you can see that only admin server is started, and we need to make sure that the admin server can see both the node managers. Go to machine 2, monitoring, and you can see the admin server can talk to node manager on node 2, and click on machine 1, and obviously it will show reachable. That means admin server can talk to both the node managers on both the nodes. So now we can start the servers. Now node manager will be able to start the servers on both the nodes. Let them start. All the servers have started now. Let's see whether we are able to access OAM console from node 1. Now we are able to access OAM console from node 1. Now let's see whether we are able to access OAM from both the nodes or not. 14,100 OAM server logout. So this is a simple URL to validate whether we are able to access manager from both the nodes. Node 2. Now we are able to validate that we are able to access our access manager from both the nodes. This completes cluster configuration. Now we need to create AWS application load balancer to balance the load or traffic between node 1 and node 2 as specified in our diagram. Let's create a load balancer. In AWS, you can see a load balancing section. Under load balancing section, you can see load balancers and target groups. Load balancers will always be pointed to target groups. Target groups are nothing but our application servers. So we need to group them. Let's click on target groups. We don't have any target groups here. Let's create target group. I can say OAM 7001 target group. We have two different port numbers. 7001 is for admin server, which is running on node 1, and 14,100 is for OAM 1 and 2, which is running on both the servers. So let's create two target groups. One target group will be 7001 and second target group will be 14,100. And it is an instance and the port number will be 7001 and it's a HTTP protocol and the health check path will be console login form.jsp, which is pretty much, you can see it here. While you're logging, you will get that URL. Click create and then close. You can see one target group is created, but it doesn't have any targets. We need to specify the target, which is OAM node 1 and the port number is 7001. We will have only one instance here because our admin server is running on node 1. It's not running on node 2. Click save and you can see the status is unused. Until we create a load balancer, the status will show it as unused. And you can see the health check that we created. Now let's create a target group 2, which is OAM 14,100. And it is instance HTTP and the port number should be 14,100 and the protocol will be HTTP and the path, health check path will be OAM server logout, which we have seen here. It's just a health check URL. Click create. Now you can see 14,100 is created, but it doesn't have any targets. Add OAM node 1 and 2 on port number 14,100. Click on add registered. Now you can see both the targets were registered. That means whatever the traffic which is coming on 14,100 will be transferred to both the nodes on round robin fashion. Click save. Now you can see the status is still showing as unused because we haven't created load balancer yet. And health check OAM server logout. Now let's go ahead and create our load balancer. Click on create load balancer, select application load balancer, and what are the name? OAM LB. Either you can choose internet facing or internal. Internet facing is nothing but you can access this particular load balancer anywhere from internet. If it is internal, that means you can only access this load balancer internally within your VPC or within your network. And it's IPv4 and the load balancer protocol. So here are the listeners that we need to configure. Listeners are nothing but they listen incoming traffic. So the incoming traffic will be coming on HTTP port number 7001. You can specify HTTPS if you have SSL certificate, but we don't have an SSL certificate. So we only specify HTTP protocol. And we should have two listeners because the traffic is coming from 7001 as well as 14,100. And availability zones, we can select 3 availability zones so that our load balancer will be highly available, and configure security settings. We'll give you a warning that we are not using HTTPS protocol because it's a security concern if you are exposing your load balancer as HTTP. Let's configure security groups. We don't have any security group for the load balancer. So let's create a security group and name it as OAM LB security group. And it should be receiving traffic on 7001 and 14,100 port numbers from anywhere in the world. I don't want to keep it open, so I'll keep it restricted to my IP address instead of opening it to the world. And then click configure. Here it will show you target groups configuration for the load balancer. I have an existing target groups and I can say OAM 14,100, which is, and I can only choose one, But once I create a load balancer, I can add another one, 7001, and then register targets. You can see for 7001, we have only one instance as target. Next, review, and then create. Our load balancer is created. Now you can see the load balancer and its availability zones and its security group. If you want to add any other rules, you can add rules in the security group. Now go to listeners. You can see we have 2 listeners added automatically, even though we selected only OAM 7001 as a target group. So it added the same target group for both the traffic. Let's edit 14,100 and then delete this forwarder, or you can edit the forwarder, and instead of selecting OAM 7001, you can say OAM 14,100. Just click on update. So what is happening here is when load balancer is receiving traffic on 7001, it will forward the traffic to OAM 7001 target group, which has OAM node 1. When it is receiving traffic on 14,100, it will forward the traffic to OAM 14100 target group, which has both the instances attached. Now we need to make sure that the target groups are healthy so that we can access the load balancer. You can see OAM 7001 started showing healthy and OAM 14,100 started showing healthy. That means our load balancer is able to talk to these health check URLs on our both machines. Now let's go to load balancers and get the DNS name of the load balancer and then try to access our 7001 console using the load balancer. Now you can see we are able to access our OAM domain, and you can see all the services are running. Now use the same load balancer and say OAM console. You're able to access OAM console from 7001. And using the same load balancer, 14,100 OAM server logout. Now you can see you're able to access 14,100 OAM server logout. So the load balancer will route the traffic to both the servers on round-robin fashion. This is how you configure a cluster and route the traffic from our load balancer. This is how you configure load balancer to route the traffic to a WebLogic cluster. I hope this video has helped you in understanding how you can manage Oracle WebLogic cluster in AWS Cloud using AWS application load balancers. Thank you.